So yes students, a very good evening to one and all present here, third semester students, and welcome to Enlightened Educators. So today we are having a discussion on the topic say source transformation. I told you that I would be handling with respect to two of the problems, that is this particular problem and this particular problem. See, with respect to this particular problem, I'm sorry, please wait. Okay. So with respect to this particular problem, there is some glitch students actually. So you can see that there was one same kind of problem with respect to this particular problem, right? There was a resistance in between and voltage was on the other side. Voltage and resistance were interchanged. So in the place of this resistance, there was an voltage, and in place of this voltage, there was a resistance, right? I hope you know that problem and we have already solved it, right? Today I'm going to share the link of that in the description box below so that you can check it out in both the videos, right? But in this problem, there is some glitch wherein I hope that the answer that is being written here, there is some problem. So let me check with this problem and teach you, right? I'm not going to take this problem into this live session today. I'm going to do it in further only in the normal classes, right? No live session for this problem. So today, that is why I told you, I'll just check with this problem and provide you the proper update for this problem. Okay. So today I'm not going to take up this problem. That is 1B. I'm going to take up this particular problem today. Let us solve this only this particular problem. There is some problem with respect to the problem. I'll update it soon and I'll take as a normal class. So please do make sure that you just follow that without fail and follow this also without fail and learn all the things in the crash course session. Okay, so crash course session is very much important for you. As I already told you, you are going to learn all the concepts within 2 sessions, right? That means each and every concept we are going to learn within 2 sessions. Whatever I tell in the one single session, that is with respect to the introduction of the concept and what is inside that concept and how to solve the problems on that concept. If I'm going to tell you all this in details in one session, so please do make sure that you follow that, so that if you see that one complete session consisting of the concept introduction and what and all is present on the concept and how to solve the problems for that concept and general that is the what I can say general steps and procedure to solve that problem, and if there is any modifications in the problem, so how to solve for that, that is what I call it as tips and tricks for solving those problems if there is any modification. We are going to discuss in general in the sense we have the general procedure, right? That means we have the general, I'm sorry, we have the general diagram, right? For that we are going to see how to solve that particular general diagram. So for that general diagram only we provide the general procedure, right? So that one we are going to discuss. After that, we are going to see if there is any modifications in the general diagram. Say, if there is any small modifications in the general diagram, if by using the general diagram only the question is given quite different. So how to solve for that problem and what are the tips and tricks that we are going to learn. And in the next session, we are going to learn the two of the problems, right? If you follow this much, if you follow the very first session itself, that means for the source transformation, this is the very second session consisting of two problems. And for what I can say here, this one, which one? And for what I can say, your source transformation. What is the first session that I have done? If you follow that, you can do any problem whatever you get. You can do any problem whatever you get in an examination. You don't need to just work it out, right? When you just see the problems only, you'll understand what you have to do, right? So that session you see first. First session you have to see, then come to the problematic session. Okay, so if you see that much, you can easily crack your examination without it. You need not to see our playlist in detail, right? You need not to see our playlist in detail. We have machine network analysis playlist. You need not to, what I can say, see that in detail, right? Okay, so I'll just showcase to you about that also. So you need not to, what I can say, see that playlist in detail, right? See here, here is what I can say here, playlist, right? So I'll showcase to you the playlist. Okay, So here is what is the playlist mesh network analysis. You need not to see this complete playlist. You can only see what I can say. You can only see the which one. You can only see what I can say the network analysis crash course playlist, so that you can easily crack your examination without fail. What? You can easily crack your examinations without fail. So you need not to see this mesh network analysis playlist. You can easily see the network analysis crash courses to crack your examination. And if anybody is very keen to watch that, you can watch that. I'm not telling that you need not to watch that. And in a simple words to say, ನಾನು ಹೇಳ್ತಾ ಇರೋದು ಮಿಡ್ ನೆಟ್ವರ್ಕ್ ಅನಾಲಿಸಿಸ್ ವಾಚ್ ಮಾಡಲೇಬೇಡಿ ಅಂತ ಹೇಳ್ತಾ ಇಲ್ಲ. ನಾನು ಏನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ, ನೀವು ಅಕಸ್ಮಾತ್ ಆಗಿ ಏನಾದರೂ ನಿಮಗೆ ಟೈಮ್ ಸಿಗ್ತಿಲ್ಲ ಈ ಪ್ಲೇ ಲಿಸ್ಟ್ ಅನ್ನ ನೋಡಲಿಕ್ಕೆ, ಅಥವಾ ನಿಮಗೆ ಟೈಮ್ ಕಮ್ಮಿ ಇದೆ ಅಂಡ್ ಈ ಪ್ಲೇ ಲಿಸ್ಟ್ ಅಲ್ಲಿ ಇರುವಂತ ವಿಡಿಯೋನ ನನಗೆ ಡೀಟೇಲ್ ಆಗಿ ನೋಡಕ್ ಆಗ್ತಾ ಇಲ್ಲ ಅನ್ನೋರಿಗೆ ದಿಸ್ ನೆಟ್ವರ್ಕ್ ಅನಾಲಿಸಿಸ್ ಕ್ರಾಶ್ ಕೋರ್ಸ್ ಪ್ಲೇ ಲಿಸ್ಟ್ ಇಸ್ ದ ಬೆಸ್ಟ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಅಂಡ್ ಇಫ್ ಎನಿಬಡಿ ವಾಂಟ್ಸ್ ಟು ಸಿ ದಟ್ ಇನ್ ಡೀಟೇಲ್ ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ವಾಚ್ ದಟ್ ವಿತೌಟ್ ಇಟ್. ಅರ್ಥ ಆಯ್ತಾ? ಸರಿಗಾದ್ರೂ ಟೈಮ್ ಕಡಿಮೆ ಇದೆ, ಇವಾಗ ಆಲ್ರೆಡಿ ನಿಮಗೆ ಟೈಮ್ ಕಡಿಮೆ ಇದೆ ಅಲ್ವಾ? ಸೊ ನಿಮಗೆ ಟೈಮ್ ಕಡಿಮೆ ಇದೆ ಅಂಡ್ ಈ ಕಡಿಮೆ ಟೈಮ್ ಅಲ್ಲಿ ನೀವು ಬಂದ್ಬಿಟ್ಟು ಓದ್ಬೇಕು ನೆಟ್ವರ್ಕ್ ಅನಾಲಿಸಿಸ್ ನಾನು ಈಸಿಯಾಗಿ ಕ್ರಾಕ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ನೆಟ್ವರ್ಕ್ ಅನಾಲಿಸಿಸ್ ಕ್ರಾಶ್ ಕೋರ್ಸ್ ಪ್ಲೇ ಲಿಸ್ಟ್ ಇಸ್ ದ ಬೆಸ್ಟ್. ಅಂಡ್ ಇಫ್ ಯು ಆರ್ ವೆರಿ ಇಂಟ್ರೆಸ್ಟೆಡ್ ಟು ಸಿ ದಿಸ್ ಮಿಸ್ ನೆಟ್ವರ್ಕ್ ಅನಾಲಿಸಿಸ್ ಪ್ಲೇ ಲಿಸ್ಟ್ ಆಲ್ಸೋ ಯು ಮೋಸ್ಟ್ ವೆಲ್ಕಮ್ ಟು ವಾಚ್ ಇಟ್. ಓಕೆ, ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಟೈಮ್ ಕಮ್ಮಿ ಇದೆ, ಬೇಗ ಕಲಿಬೇಕು ಅನ್ನೋ ಒಂದು ಕಾರಣಕ್ಕೆ ನಾನು ತುಂಬಾ ಶಾರ್ಟ್ ಅಂಡ್ ಸ್ವೀಟ್ ಆಗಿ ಎರಡೆರಡೇ ವಿಡಿಯೋ ತಗೋತಾ ಇದ್ದೀನಿ ಫಾರ್ ಈಚ್ ಅಂಡ್ ಎವರಿ ಟಾಪಿಕ್. ರೈಟ್, ಫಾರ್ ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ಟಾಪಿಕ್ ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಟೂ ವಿಡಿಯೋಸ್ ಅಂಡ್ ಆ ಎರಡು ವಿಡಿಯೋಸ್ ಅಲ್ಲಿ ನಾನು ನಿಮ್ಗೆ ಎಲ್ಲಾನು ಕವರ್ ಅಪ್ ಮಾಡ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ದಯವಿಟ್ಟು ನೀವೇನ್ ಮಾಡ್ತೀರಾ ಅಂತಂದ್ರೆ ಹೋಗ್ಬಿಟ್ಟು ಬೇಗ ಬೇಗ ವಾಚ್ ಮಾಡ್ತೀರಾ, ಆದಷ್ಟು ಬೇಗ ಎಲ್ಲ ಕಡೆ ಪ್ರಮೋಟ್ ಮಾಡ್ತೀನಿ. ದಯವಿಟ್ಟು watch this videos without fail. Okay, now coming on to this. So now coming on to this, as you can see over here, the question is given as follows. Reduce the network shown in the figure question number 1A to a single voltage source in series with a resistance between the terminals A and B. That means what? So see here, you can see that you have to convert this into a single voltage source in series with the resistance, like the single voltage source in series with the, this is V and R. Okay, this one you have to convert it into. So now here let me observe the problem properly. First problem na clean agi observe ಮಾಡಬೇಕು. You should not what I can say leave that problem. Clean agi problem na observe ಮಾಡಿ. What and all we have learned today? We have learned today with respect to what? The very first one we have learned today is ideal voltage source, IVS in series, right? We have learned ideal voltage sources in series. Okay, and the second one we have learned is nothing but what I can say, the practical voltage sources in series, PVS in series, the same thing. And the third one we have learned what? Third one we have learned is ideal current source in parallel. So this is parallel, I hope you know, right? Okay, so practical old current sources in parallel we have learned, right? Yes. Okay, and we have also learned with respect to ideal not ideal voltage source, it is practical voltage source, we'll take practical current source only first as we come to that. Practical current sources and series also we have learned in the today afternoon's live session, and we have also learned with respect to practical voltage sources in parallel. We have also learned all this, right? If you know all this, you can easily attempt any of the questions given in the source transformation topic. So for that, what is that you have to do is you need to know all this and then start analyzing the question. So now taking all this into consideration, let us analyze the whole problem, right? Let us analyze the whole problem. So I just erase this so that you can easily see the question. Okay. So I wrote this because whatever we learned, I have to brush it out, right? Yes. And please do remember, I'm sorry. Please to remember all these things without fail so that it will be very much helpful. And ದಯವಿಟ್ಟು ಎಲ್ಲರೂ ಲೈವ್ ಸೆಷನ್ ನ ಏನ್ ಮಾಡ್ತೀರಾ, ಲೈವ್ ಸೆಷನ್ ನ ವಾಚ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀರಾ. ಇಟ್ ಇಸ್ ಫಾರ್ everybody can watch it and comment. Fine. Okay. So here you can see that there is a voltage in series with a resistance and voltage in series with a resistance, as you can see over here. Right? That means this whole thing, what I can say, this whole thing is what I can say, the I practical voltage source and series, right? This is practical voltage in series. There is an other connection over here in the middle of this 10 volt and the 3 ohm. There is another connection wherein you are going to connect, that is connected to 2 ohm, right? Don't consider that. Don't consider that. That you can keep it as it is. You need not to consider that because many people what they think, you know. So here you can see that there is a practical voltage source in series, right? Another structure of practical voltage source in series which we have already discussed in the morning session, right? Morning session, right? Yes. So but what is that going to happen, many people will think that, oh, there is a connection between this 10 volt and 3 ohm and there is a 2 ohm connection over here. So that means that if there is any practical sources in series also, I don't need to convert that ಅಂತ ಅಂದ್ರೇನು, ಇಲ್ಲಿ ಒಂದು 10 ವೋಲ್ಟ್ ಇದೆ ಮತ್ತೆ ಇಲ್ಲಿ ಒಂದು 3 ಓಮ್ ಇದೆ, ಇದ್ರ ಮಧ್ಯ ನನಗೆ ಏನಾಗ್ಬಿಟ್ಟಿದೆ 2 ಓಮ್ ಕನೆಕ್ಟ್ ಆಗೋಗ್ಬಿಟ್ಟಿದೆ ಎರಡರ ಮಧ್ಯ. ಸೊ ನನಗೆ ಇಲ್ಲಿ ಪ್ರಾಕ್ಟಿಕಲ್ ವೋಲ್ಟೇಜ್ ಸೋರ್ಸಸ್ ಅಂಡ್ ಸೀರೀಸ್ ಇದ್ರೂ ಕೂಡ ನಾನು ಅದನ್ನ ಕನ್ವರ್ಟ್ ಮಾಡೋದಕ್ಕೆ ಆಗಲ್ಲ ಅಂತ ಅನ್ಕೊಳ್ಬಹುದು. ನೋ, ಯು ಕ್ಯಾನ್ ಕನ್ವರ್ಟ್ ಇಟ್, ಯು ಕ್ಯಾನ್ ನೆಗ್ಲೆಕ್ಟ್ ದಟ್, ಯು ಕ್ಯಾನ್ ಕನ್ವರ್ಟ್ ಇಟ್, ರೈಟ್? If you convert it, you get it as what? If you convert 10 and 2, what if you convert 10 and 2? 10 and 2 ನ ಕನ್ವರ್ಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ it is I is equal to V by R, wherein which is equal to 10 by 2. 10 by 2 ಏನಾಯ್ತು? 2 ones are 2 5s are 10. You get what I can say, you get that is the 5 ampere and what I can say 5 ampere and 2 ohm here for this particular, and for this particular you get 12 by 3. So what is 12 by 3? That is 3 ones are 3 fours are, you get 4 ohm and 4 ampere and 3 ohm, sorry, 4 ampere and 3 ohm in parallel with 2 ampere and 5 volt, right? So now let us see the solution for this problem. Okay, so like that you're supposed to do and you're going to continue with respect to the problem. So then here you can see that if you have, so here I told you that it is how much? It is what I can say, the 5 ampere and 2 ohm and 3 ampere and 2 ohm. So what is that going to happen? You are going to get 5 ampere in parallel with 2 ohm and 3 ampere in parallel with 2 ohm. If you get that, so in this particular case you will get it as that as practical current sources and what I can say the parallel. Practical current sources in parallel ಬರುತ್ತೆ, ಅದನ್ನ ಮತ್ತೆ simplify ಮಾಡ್ಕೊಳ್ತೀರಾ and we are going to discuss it further with respect to that. Okay, so shall we move on? Yes. So I am showing you the scheme of valuation so that you just understand what is that methodology they have used to you, and this is very much important. ಈ ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ನೀವು ನೋಡಿಲ್ಲ ಅಂತಂದ್ರೆ ನಿಮ್ಗೇನು ಗೊತ್ತಾಗೋದಿಲ್ಲ. ನಿಮ್ಗೆ ವಿ ಟಿ ಯುದು ಒಳಗಡೆ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ವಿ ಟಿ ಯುದು ನಿಮಗೆ ಹೇಗೆ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತಾರೆ ಅನ್ನೋದು ಗೊತ್ತಾಗ್ಲಿ, ಸ್ಟೂಡೆಂಟ್ಸ್ಗೂ ಎಲ್ಲ ಗೊತ್ತಾಗ್ಲಿ ಅನ್ನೋ ಒಂದು ಯೋಜನೆಯಿಂದಾಗಿ ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಅನ್ನ ಮಾಡಿದ್ದಾರೆ. ವಿ2 ಫಾರ್ಮುಲಾ ಬುಕ್ಲೆಟ್ ಅನ್ನ ಮಾಡಿದ್ದಾರೆ. ನಾನು ಆದಷ್ಟು ಬೇಗ ಫಾರ್ಮುಲಾ ಬುಕ್ಲೆಟ್ ಬಗ್ಗೆ ಅಪ್ಡೇಟ್ ಮಾಡ್ತೀನಿ. ಥರ್ಡ್ ಸೆಮ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಇದೆ, ಯಾವುದೇ ಭಯ ಬೇಡ. ಅಂಡ್ ಥರ್ಡ್ ಸೆಮ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಇದೆ, ಯಾವುದೇ ಭಯ ಬೇಡ. ಅಂಡ್ ನಿಮ್ಮ ಒಂದು ಥರ್ಡ್ ಸೆಮ್ ಇದು ನೆಟ್ವರ್ಕ್ ಅನಾಲಿಸಿಸ್ಗೆ ಇದೆಯಾ ಅನ್ನೋಂಥದ್ದನ್ನ ನಾನು ಬೇಗ ಕ್ಲಾರಿಫೈ ಮಾಡಿ ಹೇಳ್ತೀನಿ, ರೈಟ್? ಬಿಕಾಸ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ಗೂ ಇದ್ರಿಂದ ಇದಕ್ಕೂ ಇರೋ ಸಾಧ್ಯತೆಗಳಿದೆ. ಇದಕ್ಕಿದ್ರಂತೂ ನಿಮ್ಮಷ್ಟು ಅದೃಷ್ಟವಂತರು ಇನ್ನೊಂದಲ್ಲ, ನಿಮ್ಮಂತ ಅದೃಷ್ಟವಂತರು ಇನ್ನೊಂದಲ್ಲ. ಸೊ ವೆರಿ ಮಚ್ ಹ್ಯಾಪಿ. ಓಕೆ, ಯಾ. So see, I told you, no, this is 5 ampere and 2 ohm anta helde, and this is 4 ampere and 3 ohm I told you, right? Now this I told you that it is a practical current sources and what? It is a practical current sources and parallel. So I told you how to convert that. If you convert that, you get 5 and 3. What is 5 and 3? 8. And here it is 2 and 2. What is 2 and 2? 2 into, I'm very sorry for the distraction. Please wait, students. Okay. Yeah. So 2 and 2, which is, 2 into 2 divided by 2 plus 2, which is equal to what? 2 twos are 4 and 2 plus 2 is 4. You get it as 4 by 4, which is equal to 1. We got 8 ampere and 1 ohm. Now here comes 2 ampere and 3 ohm. So what is 2 ampere and 3 ohm? So here it is 4 ampere. I'm sorry, this polarity is different and this polarity is different. If you consider like this, the arrow mark, so you can see that this is positive and negative. And if you consider like this, you get negative and positive. What? If you consider like this, you get negative and positive. So what is that going to happen? So what is that going to happen is that since the polarities are different, so if you consider with respect to the polarity, as per the current, it is direction only. But what I am telling you is, ಇದು current ಗೆ direction. But ಏನಾಗ್ತಾ ಇದೆ, ನಾವು arrow mark ನ positive ಅಂತ consider ಮಾಡ್ತೀವಿ current ನಲ್ಲಿ, tip ನ negative ಅಂತ consider ಮಾಡ್ತೀವಿ current ನಲ್ಲಿ. So ಹಾಗಾಗಿ I have written that ಅಷ್ಟೇ. But for a current, it is the directions itself. Okay. So directions ಅಲ್ಲಿ ನಾವು arrow mark ನ ಏನಂತ consider ಮಾಡ್ತೀವಿ and the ಟಿಪ್ ನ ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ನಾವು ಬರಿತಾ ಇದೀವಿ ಅಷ್ಟೇ. ಡೋಂಟ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ಡ್. ಓಕೆ. ಸೊ ದ ಆರೋ ಮಾರ್ಕ್ಸ್ ಆರ್ ಡಿಫರೆಂಟ್. So you have to subtract. So when you subtract, you get 2 ampere and this see 2 ampere again ಬರೆದಿದ್ದಾರೆ. This direction they have taken. Why this direction they have taken for the 2 ampere? Why this direction they have taken for the 2 ampere is because you can see that the direction of the 4 ampere and the direction of the 2 amperes are different, and you can see that in both the current 4 ampere is the highest. I told you in the morning that even with respect to the voltage, if we have different polarities, you have to subtract or add according to the polarity. That means I have to subtract actually. Subtract according to the polarity and then you have to consider the polarity of the highest voltage. And for the current also I told you the same in the morning session that if you have the currents of different polarities, you need to make sure that you are going to add or subtract according to the polarities and you have to consider the highest current polarity. So here the highest current is 4 ampere. This highest current is 4 ampere and the polarity of the 4 ampere is there. So therefore we have to take that polarity. So that polarity of the direction here. So you can see the direction is taken. Okay. Yes. And now what is that you're supposed to do here? See, they have given you some statements. I'll just tell you. Okay, please wait. Yeah. Yeah. See, the first statement is replacing 10 volt, 12 volt and 5 volt voltage sources by their equivalent current sources ಅಂತ ಹೇಳಿದ್ದಾರೆ. 5 volt ದು ಯಾವುದು ಅಂದ್ರೆ ಇದು. I'm sorry, I just did not tell you that I guess. So 5 volt ದು ಏನಾಗಿದೆ ಇದು. 5 volt and 2 is converted to I is equal to V by R. So you get it as 5 by 2. So 2 ones are 2 twos are you get 2.5. That is also converted. ಹೌದಾ? ಅದನ್ನು ಅವ್ರು ಏನಕ್ಕೆ ಬರ್ದಿದ್ದಾರೆ? They've written because evaluator wants to know that, right? So ನಿಮ್ಮ representation ಹೇಗಿರಬೇಕು ಅಂತ ಇಲ್ಲಿ ಗೊತ್ತಾಯ್ತಾ? You got to know how your representation should be, right? Did you get it? Yes, you got it now. Fine, you got it now. Okay. So here you can see that you have to first write step by step. So when you write step by step, first you have to write the content for that step. See here, in this step what they have done is, they have replaced the 10 volt, 12 volt and 5 volt. So illenittu 10 volt in series with 2 ohm ittalva ee jagadalli. In this place it was 10 volt in series with 2 ohm, right? Okay na. And here also you had 5 volt in series, 5 volt in series with what? 5 or 12, 12, I'm sorry, 12. Okay, 12 volt in series with you had some 3 ampere. You had that, right? You had that, right? Is it not? Okay. So, and here you had 5 volt in series with 2 ohm, right? So, that one you're going to replacing it by the equivalent current source. So, you're doing that. That is what is the first step. So, you're going to write the very first step in this form of statement and then write that particular diagram. If you don't write that, what is that going to happen is evaluator will not even look at that, right? Evaluator doesn't have time or patience to look at that, because your results has to be released within 10 days of your examination. And what is that going to happen is evaluator will have only 1 or 2 minutes to correct your paper. They'll correct the papers in a faster and a neat manner. So that is why, so if they get very less time to correct your paper, they don't even look at what is that you're going to do in this step. What they'll do is, to be frank, what they'll do is that they will just, what I can say, see the writings of this. They just see the writings of this, and according to the writings of this, say here they've written replacing 10 volt, 12 volt, and 5 volt voltage sources by equivalent current source. They have written. So they'll just look at this and they'll just see whether they have done it correctly, and then they'll move on, friend. So that is why try to write the statement for any of the steps. If you are converting the diagram into any of the things, so you're going to make sure that ಡಯಾಗ್ರಾಮ್ ನ ಕನ್ವರ್ಟ್ ಮಾಡ್ತಿದ್ರೆ ಆ ಡಯಾಗ್ರಾಮ್ ನ ನೀವೇನ್ ಮಾಡ್ಬೇಕು, ಆ ಡಯಾಗ್ರಾಮ್ ನ ಕನ್ವರ್ಟ್ ಮಾಡೋದಕ್ಕೂ ಮುಂಚೆ ಏನ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅಂತ ಒಂದು 1 or 2 ಲೈನ್ಸ್ ಅಲ್ಲಿ ಬರೆದ್ಬಿಟ್ಟು ಆಮೇಲೆ then you have to write the converted diagram. That is what is you have to do, or else it will not be a very good sense for the evaluator. Fine. Okay. So now after the, see here, see this one also they have written. See, 5 ampere and 3 ampere current sources are replaced by 8 ampere, 4 and 2 are replaced by 2 ampere ಅಂತ ಬಂದಿದ್ದಾರೆ. See, they'll not get to know all these things. They know all these things, but they don't have the patience to see, because they have to correct n number of papers. They have to correct n number of papers, and they can't just sit in your paper and just look at your paper in detail, right? They don't have that much of time. The very first thing, ನಿಮ್ಮ ಪೇಪರ್ ನ ಕೂತು ಡೀಟೇಲ್ ಆಗಿ ನೋಡೋಷ್ಟು ಸಮಯ ಇಲ್ಲ ಅವರಿಗೆ. ಸೊ ನೀವೇನ್ ಮಾಡ್ಬೇಕು, ಏನೇ ಕನ್ವರ್ಷನ್ ಮಾಡ್ಬೇಕು ಅದು ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ, you need to write that conversion on the form of 1 or 2 lines, and then you have to what? Then you have to write the converted diagram, right? So that what they'll do is they'll just see the statement. They'll just see the statement, and then they'll just see whether that is converted or not, whether they have done that properly or not ಅಂತ ಚೆಕ್ ಮಾಡ್ತಾರೆ. So ಇಲ್ಲಿ ಏನು ಹೇಳಿದ್ದಾರೆ, 5 and 3 current sources are replaced by 8 ampere ಅಂತ. So here you can see what? Here you can see that this what I can say, the 5 and 3 ampere is replaced by 8 ampere. They have done it. See, and 4 and 2 are replaced by 2 ampere. They have done it. So that they will consider it as correct and then move on. Right? So that is what is the agenda for the evaluators. So please to understand the evaluators and work it out. Fine. And this is what is the proper and neat representation for this problem, or else you will not, it is not a good sign for the evaluators. Right? Okay. Now see, replacing 8 ampere and 2 ampere by equivalent voltage sources. What is that you are supposed to do is, you are supposed to write it on the top of the diagram itself. So nodili illi baradbiಟ್ಟು diagram na illi ಬರ್ದಿದ್ದಾರೆ. Don't take that into consideration. What is that you are supposed to do is, after you write this diagram, ಈ diagram ಆದ್ಮೇಲೆ just write this on the here itself and then write the diagram. So ಈ diagram ಆಗುತ್ತಲ್ಲ, so I'll just tell you, please wait. So you write first this one and then this one, right? After that, take this whole thing and write it over here, and then write this diagram. Okay, this whole thing has to be written over here and then write the diagram. Fine, you got it? Okay. Now replacing 8 ampere and 2 ampere by the equivalent voltage sources. So see, this part has to be written over here and then the diagram. So 8 and 2 are replaced by their voltage sources. Now you can see that this particular thing is nothing but your practical current sources in series. What? Practical current sources in series. That is why I told you, please to learn all those, or else you can't even get to know what is the things, right? This is practical voltage sources in series. Okay. If practical voltage sources in series, if you convert once again, you get practical voltage sources in series. Practical current sources in series, if you convert, you get practical voltage sources in series. You should have that much of idea. Right? Okay. This is practical voltage sources in series, and 8 and 1. So 8 and 1 will become equal to what? 8 and 1 will become equal to 8 and 1 only, because V is equal to IR. That is 8 into 1 is 8 ohm. Right? 8 volt and 1 ohm. Okay. And here this is 2 and 3. So IR. So 2 3s are what? 2 3s are 6. So this is 6 volt and 3 ohm. Right? And this is 2.5 ampere and 2 ohm. Right? Now you have what? You have the practical voltage sources in series. Now we have to add this to 6 and 8 is added, which yields to 14, right? So 14, and then what is that you're supposed to do is, don't write anything over here. After this diagram, After this diagram, don't write any statement. Just what I can say, just convert this first. Convert the practical voltage sources in series to do the conversion. That is 6 plus 8 is 14 and this 1 plus 3 is 4 you do. Okay, now after you do that, then come to this 2.5 and 2 have to write it as it is 2.5 ampere and 2 ohm have to write it as it is, right? And the direction of this 2.5 ampere I will just tell you. So please wait. So here you can see that this is what I'll just to make it bigger. Yeah. So see here this 5 volt is nothing but negative and positive sign 5 volt. So this one also I have to remember. So if the 5 volt sign convention is negative and positive according to your arrow mark it is this. If it is positive and negative in your voltage according to the arrow mark it is this. So for this one the arrow mark is this. So that is why they have taken it as what I can say the this particular arrow mark. Okay, hope you got it. Yeah. And now what is that going to happen? You have got just a single practical voltage source in series. So now just convert this into the parallel. So if you convert it into parallel, I is equal to V by R wherein 14 by 4. So 2 2s are 2 7s are. So 7 by 2 is 3.5. So this is 3.5 ampere. The direction is this one because it is positive and negative students. Positive and negative. I hope you got it. Yes. So now we are teaching it in detail. Sana sana maataru tilustadivi dayavitu watch ಮಾಡಿ. And please don't think that a mom doesn't know anything so that she is doing this in the scheme of valuation anta. No, I am showing you the scheme of valuation for the crash course students because they need to know what and all they are expecting in scheme of valuation, and you need to understand that, and according to that you need to work. So I thought the scheme of valuation is the very best methodology for you all, right? Scheme of valuation is the very best methodology for you all. So that is why what I planned is I just thought of showing you the scheme of valuation, telling you what is inside it and how to represent for an evaluator. That much also you need to know, no? So that is why I'm using this, right? I can even do this in a sheet of paper, but I thought that was not a good sign, right? Okay. So I have an idea how to do it, how to train you all, how to bring you to the good extent. So that is why I'm working on all this, and please don't take me wrong and see this and understand this and work it out like this will impress your evaluator. You will get full and full marks without any hurdles. Fine, I'm guaranteed for that. Okay, yeah. And the next thing is you did this, right? Now 3.5 and 2.5. Here also students, it is a different sign, a different, what I can say the arrow mark. The arrow mark is different. So once again you have to subtract and you have to write the 3.5 ampere the arrow mark because it is highest. Okay. No, sorry, 2.5. Okay, 2.5 is supposed to, right? I'll just tell you about that. So see here you can see that what is 4 and 2. So 4 and 2 is nothing but is equal to what I can say the 4 and 2 is nothing but is equal to what I can say the 8 by 6. So it is 4 into 2 divided by 4 plus 2, which is nothing but 4 2 is 8 and 4 plus 2 is 6. So this is 8 by 6 here. This is 8 by 6 ohm, and here you can see that 3.5 and 2.5. So now you have to subtract. What have to subtract? 3.5 minus 2.5. So let me do that. 3.5 minus 2.5 is yielding me what I can say the, here they are considering it as 8 by what I can say the 6 volt student. So just a minute, I'll just check with this without fail. This is coming, so here it is. Okay, here it is students, yeah. So here it is, you have 1 ampere and here you have to write the sign convention of what? I'm sorry, I just checked with this, I'm sorry. Here this is 1 ampere and 1 ampere sign convention is nothing but you have to take this 3.5 ampere the arrow mark because it is the highest. Fine. Which is the highest you have to take that arrow mark, or which is the highest you have to take that sign convention. Sign convention is for voltage. So highest voltage value the sign convention ತಗೊಳ್ತೀರಾ and highest current value the direction ತಗೊಳ್ತೀರಾ. Fine. Okay. In the case of current and voltage respectively. This is 8.6 ohm and here is the terminal A and B. Don't forget to write the terminal A and B, you will lose the marks, right? And after that here you can see that, so see here replacing 14 volt by current. So this is for this diagram. You have to write it. After that you have to simplify this diagram. For simplify this diagram you need not to write any statement. Just simplify this diagram and this whole thing is looking like what? This whole thing is looking like what? Yeah, practical current sources in parallel. This is practical current sources in parallel. You need to remember all this you have to see that particular and identified very easily whether it is ideal voltage sources in series or practical voltage sources in series or practical voltage sources in parallel. You have to what I can say, see the diagram and you have to immediately identify. That is what is you have to do. That is why I taught you all the tricks so that you have to follow that and that. Fine. Okay. And yeah. So after this, we need to once again convert it into voltage in series with the resistance, because the question is asked that you have to convert it into a voltage in series with the resistance anta. So for that, what is that you're supposed to do? You're supposed to do is that you have to convert the voltage in series with the resistance. So now we have got 8 by 6 ohm into 1, because I is equal to V is equal to IR, wherein 1 into this 8 by 6 ohm is 8 by 6 volt, and this direction is like this, so it is plus and minus. So therefore it is plus and minus 8 by 6 volt, and this is 8 by 6 ohm resistance connected to terminals A and B. I hope you got the problem. I hope you got to know how to write an answer for this problem. ಸೊ ನಿಮಗೆ ನಾನು ಹೇಳ್ಕೊಡ್ತೀನಿ ನೋಡಿ. ಐಡಿಯಲ್ ಪ್ರಾಕ್ಟಿಕಲ್ ವೋಲ್ಟೇಜ್ ಸೋರ್ಸಸ್ ಇನ್ ಸೀರೀಸ್, ಪ್ರಾಕ್ಟಿಕಲ್ ವೋಲ್ಟೇಜ್ ಸೋರ್ಸಸ್ ಇನ್ ಪ್ಯಾರಲಲ್, ಪ್ರಾಕ್ಟಿಕಲ್ ಕರೆಂಟ್ ಸೋರ್ಸಸ್ ಇನ್ ಸೀರೀಸ್ ಅಂಡ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಕರೆಂಟ್ ಸೋರ್ಸಸ್ ಇನ್ ಪ್ಯಾರಲಲ್ ಇದ್ದಾಗ ನೀವೇನ್ ಮಾಡ್ಬೇಕು ಅಂತಂದ್ರೆ ಯಾವುದೇ ತರ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಬರೆಯುವಂತ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಅದನ್ನ ಜಸ್ಟ್ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಂಡು ಹೋಗಿ. ಇಫ್ ಯು ಆರ್ ಡೂಯಿಂಗ್ ಎನಿ ಮೇಜರ್ ಚೇಂಜಸ್, ಎಲ್ಲಾರು ಒಂದ್ ಕಡೆ ಮೇಜರ್ ಚೇಂಜಸ್ ಮಾಡಿದಾಗ ನೀವೇನ್ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ, have to write it in terms of statement. Like say for example here you can see that they had made a major changes, so ಅದಕ್ಕೆ ಬರ್ದಿದ್ದಾರೆ ನೋಡಿ. ಇಲ್ಲೂ ಕೂಡ ಅವ್ರು ಏನ್ ಮಾಡಿದ್ದಾರೆ, ಮೇಜರ್ ಚೇಂಜಸ್ ಅನ್ನ ಮಾಡಿದ್ದಾರೆ, ಸೊ ಹಂಗಾಗಿ ಬರ್ದಿದ್ದಾರೆ. and here you can see that here they have just simplified it, so ಇದಕ್ಕೆ ಅವ್ರೇನ್ ಬರ್ದಿಲ್ಲ. and here they have done one major changes, so they have written it. so ನಿಮ್ಗೆ ಎಲ್ಲೆಲ್ಲಿ ಬೇಕು ಅನ್ಸುತ್ತೋ ಅಲ್ಲಿ ಬರೀರಿ. if you are very much comfortable, write a statement for each and every diagram and then just convert. ಆಯ್ತಾ, ಇಲ್ಲಿ ಇಷ್ಟ ಡಯಾಗ್ರಾಮ್ ಅದೇ ನೋಡಿ. 1 2 3 4 5 6 7 ಡಯಾಗ್ರಾಮ್ಸ್ಗೂ ನೀವು ಒಂದೊಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಬರೀತೀರಾ, ಬರೀರಿ, ತುಂಬಾ ಸಂತೋಷ. ಇವ್ಯಾಲ್ಯೂಯೇಟರ್ಗೆ ಇನ್ನೂ ಖುಷಿ ಆಗುತ್ತೆ. You can just do that without fail, right? So this is what is for today's session. Please do follow this today's live session, and please do what? Please do follow this today's live session, and please do watch it, and please do put a comment, students, so that we will get a very good response from you all anta helta. I'll just wind up the session, students, and please do watch all the sessions without fail. Crash course the watch ಮಾಡಿ, so that you can easily crack your exams without any hurdles. You will not be tensioned or you will not be worried. You can easily crack it within 2 sessions. You can learn any of the topics with respect to network analysis by following our network analysis crash course anta ಹೇಳ್ತಾ. Thank you, students.